Hello, honors chemistry, and welcome to chapter 5, section 5.8, naming molecular compounds. So, ionic compounds are the most challenging part. The rest of this gets pretty simple. That's why we do it first, right? Get that out of the way. So, first we need to ID that a compound is molecular, right? That's always first step, right? So, previously we were looking for ionic compounds, right? Ionic compounds would be a metal and a nonmetal. Right? Or it could be some combination of polyatomic ions and metal, right? Molecular, though, right, is going to be two, it could be or more, right? We're going to stay in the land of two nonmetals, right? And if we think about what the difference is, right, in an ionic compound, right, what we really have is a cation and an anion, which means that the cation loses electrons and gives them to what becomes the anion, right? So there's an exchange of electrons. We end up with something that is positively charged, something that's negatively charged, and those opposite charges are what hold networks of those ions together, right? For a molecular compound, the bonding is different, right? Thinking back to middle school, right? These are held together by covalent bonds, right? Wherein we have two or more nonmetals in close proximity to one another, and they share their electrons, right? They share their valence electrons with each other, right? And that's what forms the force of attraction that holds one atom adjacent to another such that they become a singular unit called a molecule, right? Which is why, right, the bonding is different than in an ionic compound, right? So molecular compounds, what we're really looking for again is the presence of two or more nonmetals, right? So thinking back to our periodic table, right, what we said before, right, we are going to take this line for our metalloids, and if it is to the left, we are just going to call it a metal to be simple, right? And if it's to that side, we're going to go non-metal, right? Obviously, tennessine, probably, you know, who knows? It's not real. So, well, it's real, but we're never going to play with a sample of it, right? So, you know. So anyway, first we're looking for two or more nonmetals, and then let's name some of these because we already know these, right? So we already know that CO2 is called, right, you guys have been saying this name since you guys were probably in grade school, right, across the street somewhere. And this one you guys all know is called this. So let's think about the naming system here, right? So for the second element, right, they get a numerical prefix. Yes, this is dioxide, this is monoxide. So for the prefix, we always get a numerical prefix, right? Always get numerical prefix. And so here, obviously, we have to make sure we know our numerical prefixes. All of them are really simple. The only one that's weird is like the tetra, right? But the rest of them fall in line with all your geometric shapes that you would have learned, you know, a million years ago. All right, and then we're just going to do root and ide, right? Because this ending, which we said was for binary compounds when we did ionic compounds, still persists, right? These are still all binary compounds, right? So they still end with ide, right? So we just need to pay attention to what it's made of, right? But now we have carbon and oxygen, and if we look here, right, carbon, nonmetal, oxygen, nonmetal, so definitely molecular, right? Here we have nitrogen and oxygen, nitrogen, oxygen, also nonmetals, right? Now this one is actually called dinitrogen tetroxide, right? So again, we've got the prefix root-ide here, right? Now we have a prefix here. What differentiates CO2, CO, and N2O4? Right, that, right? So we only get a prefix on the first element if more than one. So the first element gets a numerical prefix if there's more than one, and then here we just use the whole name. Whole name of that first element, right? So in terms of what differentiates these names, right? So you might wonder, how do you figure out the formula if there's not some charges, right? But that's why these are so easy, right? Tetra, pent, di, hepta. What it's made of is already in there, right? So now let's talk about how to dissect these names so we don't get confused, right? We might see ide and be tempted to think ionic, but then we would remember, oh, all binaries end in ide, so that is not a differentiating factor. What is, though, is what it's made of, right? So this is made of silicon and some chlorine. So if we go back, And we look here, right? Silicon and chlorine are nonmetals, right? Which means that it's molecular. So that's really what you need to do, right? You can't use that "ide" as your marker here, right? We need to go figure out, is it a metal and a nonmetal or two nonmetals? Once we know it's two nonmetals, now we're just going to write what it tells us to write. This says there's 1 silicon and 4 chlorines, okay? And if you try to balance the charges, you should find, oh, well, this is a nonmetal, which means I don't even know what, because we said that these don't often form charges, right? Because of having 4 valence electrons and being in the middle. And this one is a negative, so a negative and a nothing, that doesn't make sense, right? And then you'd be like, oh, because it's molecular, right? Here, nitrogen and oxygen, right? So we go find nitrogen and oxygen. Ooh, molecular. So just write what it says. This says 2 nitrogens and 5 oxygens, right? Iodine heptafluoride. So we'd see iodine and fluorine. Iodine is here, fluorine is here. So again, 2 nonmetals. So we'll just write what it says, which is 1 iodine and 7 fluorines, yes? So again, "ide" just means binary, right? "Ide" doesn't mean ionic or molecular. "Ide" just means binary. So then we need to go figure out, is it metals and a nonmetal or just nonmetals? And then we can figure out the naming from there. Yes, does that make sense? And do be mindful about that, dropping the prefix on the, dropping the vowel on the prefix if it's next to oxygen, right? Like in the tetroxide, right? Monoxide. This one's an exception, right? All right, so that's moleculars. Again, more practice is coming, so no worries. Thank you for listening. Be good, and I will see you soon for acids.